Hello dear students, today we will start our new topic, which is algebraic identities. So basically there are a lot of identities, but for this term we will only cover these three. But what is identity? How do you define it? Okay, let me give you an example. For example, you have this kind of equation. So you know what is equation, yeah? Equation is tengdev in Kazakh, in Russian, равенство. Okay. X plus y is equal to, you could say, y plus x. So this is identity. Why? Because this is always true. So let's put instead of x2, for example, instead of y1. Yeah. So this. So we put instead of y1. So x would be 2, yeah? 3 is equal to 3. This is true. So, you can put any number, this thing will be always true. So, this kind of equations, we call identity. So, this equation, which is always true, okay? So let me start from the first identity. So which is a square minus b square, which is equal to a minus b times a plus b. So why is it so? Okay, let's open these two brackets. Yeah. You remember how to open these brackets when you have multiplication here. So what do? You multiply a by a, okay, a to a, and then a to b, and then b to a, and then b to b. Yeah, but don't forget about this minus. Okay. It will also go to this place. So a to a, first case, this one, yeah, a to a would be a to a to b. So you have plus here, a plus b, yeah? So minus b times a, it will be minus ab. Minus b times b, it will be minus b times b, yeah? So, a times a, it will be a square. This one a plus b, this one a minus b, this one minus b squared. So, since they are a plus b and minus a minus, they are like ones, that's why they are cancelled, and you have 0 here. So you only left with a square minus b square. Okay? So we proved that this kind of expressions, you could write it as a square minus b square. For example, let's say you have x minus 1 times x plus 1. You could write it as, so x would be a square, 1 b 1 square. So 1 square is just 1, x square minus 1. That's it. You could write this one as this one. So this actual identities goes from you could go from this one to this way, and from this one to this way. Okay, let's have this expression, x squared minus 25, okay? How can you write it differently using this formula. We have this formula: a square minus b square. This one is equal to a minus b times a plus b. So you should always have here squares. Okay, you have a square here, but you don't have a square here. So if you don't have, you could make it. So x squared minus, so this one is the square of 5, yeah? So this one is a, this one is b, so you can write it as a minus, you could write it as x minus 5 times x plus 5. Okay, this one is done. Let me write another example. Let's say a squared minus 4, yeah? How can you write it? You can write it as this one. So you have a squared, you could write it as 2 squared, yeah? So it will be a minus 2 times a plus 2. Okay? Third one, x squared minus 121. Yeah, this is x squared. 121. If you know, if you may know, it is the square of 11. So you can write it as x minus 11 times x plus 11. Okay. So let's say you could write it as this one. How can you write this one? 900 minus p squared. So this one, can you write it as a square? Yes, it is the square of 30. Yeah. 30 squared minus p squared, it will be 30 minus p times 30 plus p. Okay. Okay. Let me give you another example. Let's say you have this one, 61 square minus 39 square. Okay, so actually this one you could count it yourself, like finding the square of 61 times 61, and then minus 39 times 39, but it will take time. So here it will be much easier if you use this formula. So according to the formula, it will be 61 minus 39 times 61 plus 39, yeah? So here you have, what do you have here? 22, yeah? Here you have 22, and then here you have 100. So it is 2200. That's your answer. Okay, let's have this one. 25x squared minus 49y squared. What is it? So as you remember, what is the formula? A squared minus b squared, yeah? It is a minus b times a plus b, yeah? So you should have a square. This should be all the square. But here you have only x squared. What do? You could make the square, this 25. It will be 5 squared times x squared, yeah? The same would be about 49. It will be 7 squared times y squared. Okay? Then what do? So according to the rule of powers, so if you have this kind of thing like x, y, you have, for example, power m, you could write it as x to the power of m, y to the power of m. Okay? And this one works only not only this way, like this only works, also works the other way. Okay, you have here you have this thing. here. Okay, so using this this rule of the powers, you could say that 5x to the power of 2 minus 7y to the power of 2. Okay, so this, now you have the a's, this one like your a, this one like your b. Okay, so according using this formula, you could write 5x minus 7y times 5x plus 7y. Okay, so this one and this one, they equal. Okay, next example, let's say you have this one, 81x squared minus 21y squared. Okay, so how can you write it? 81, it will be 9 squared times x squared minus this one is 11 squared times y squared. So using this rule, you can see that this one is equal to, you can join these two and make common power, yeah? So 9x to the power of 2 minus 11y to the power of 2. So it will be, according to the formula, 9x minus 11y times 9x plus 11y. That's your answer. Okay, now let's repeat the multiplication of expressions. Okay, how do you multiply this kind of thing? You have b minus c times b plus c. Okay, how do you multiply these two brackets? Okay, so if you remember, you multiply b to b, b to c, c to b, and then c to c. Okay, so what do you have? B to b, b times b, and then b to c plus bc. So here you have minus, so minus c times b minus c times c. Yeah? So this one, this one would be b squared, and this one, are they equal? So bc and cb. Yeah. So actually, b times c and c times b, they are the same. There is no difference. So for example, you write 7 times 5, it is the same as 5 times 7. Yeah, they are same. So the c minus cb minus cb, this is plus, this is minus, so it will be 0 here. So here you have minus 7 squared. So this one would be equal to this one. Okay, next example. Let's have 2x minus 1 times 2x plus 1. Okay, what is the answer? So what do you do? 2x times 2x, 2x times 1, 1 minus 2x, 1 minus 1, 1 times 1, yeah? So 2x times 2x, it will be 2x times 2x, okay, 2x times 1, 1, and then minus 1 times 2x, minus 1 times 2x, minus 1 times 1, yeah? So here, you have the numbers, you multiply the numbers, it will be 4, yeah? And then you have x's here, so 2 x's. So if you multiply x's, what are their powers? This is 1, this is 1. When you multiply them, if the base are the same, the powers are added. Okay, 1 plus 1. That's why 2. So this is the according to this rule of powers, it is like x to the power of m times x to the power of n. It will be x to the power m plus n. Yeah, this is your rule. If you don't, if you remember it, so here you have x squared plus this is just 2x, this is just minus 2x This is just 1, yeah. So these two they are cancelled. So you are left with 4 square x 4 times x square minus 1. This is your answer. Okay, what about this one? So we'll do the same process. Yes. So 3m times 3m, 3m times 2k. So here you have minus, so minus 2k times 3m, and then minus 2k times 2k. Yeah, minus 2k times 2k. So what do you have here? If you multiply the numbers, it will be 9. M times m, it will be m squared. So here you have 6m plus 6 mk. Here you have minus, yeah. You could write km. So here you have minus 4 and then k squared. So they're the same. There is no difference, yeah. mk, km, they're cancelled. So it will be 9m squared minus 4k squared.